The world is full of data. If you see, the data volumes are growing day to day. If you open your mobile and click on WhatsApp, you can see all the chat history, pictures, videos, voice memos, documents that you have shared over the period of time are still available. Same is the case with your Facebook postings. If you have opened your Facebook account in 2011, since then all your postings, pictures, videos which you shared with your friends are still available. Most importantly, how your bank transactions are going through. If you just open your Bank of America app through your mobile and try to retrieve your past month transactions statement, then it is getting retrieved without any difficulty. How they are getting retrieved and where they are stored exactly. The only answer to all these questions is the database. What is a database? Every day we are dealing with data. If you are writing a diary about good and bad incidents about your daily life and your memories, then it becomes a written data of your diary. If you are storing your pictures by creating an album, it's a picture data. If you are collecting any favorite movies and keeping your videos updated into a folder, then it's a collection of video data. If I'm keeping my educational documents, certificates in a PDF format, then it becomes a document data. So, in short, if I'm arranging all the above data into a structured way to access and retrieve, it is called as database. Now, let's discuss about the changes that happen to a database and how these changes are termed as transactions in a database. What is a transaction? So, to explain transaction in simple words, that any change that we are going to do to a database is nothing but a transaction. What is a transaction? And the best example I can give you is, imagine that at this point there are 10 people logged into Amazon website and they are trying to place order on the same thing, which could be an iPhone or LCD TV or a jacket or a trouser, which is only available only one. When more than one person is trying to buy the same thing at the same time, if they are trying to order the same thing, then definitely there is a clash that is going to happen there. So at that moment, how a transaction behaves. So we need to know about that. In order to process a transaction to be successful, it has to pass through certain characteristics which are called as ACID properties in SQL Server. So now we will go in detail about what are ACID properties. In order to process a transaction or a transaction to be successful without overlapping with each other, like 10 people in Amazon website trying to place the order on the same thing, but those 10 transactions should not overlap with each other. So that is the purpose. So in order for a transaction to be successful, it has to pass through the below characteristics, like the ACID properties. What are ACID properties? So ACID stands for A for atomicity, C for consistency, I for isolation, D for durability. Now we will learn about each and individual property in detail. Now let's see about atomicity, what it says exactly. This characteristics of a transaction means that a transaction is performed completely or not at all performed. So you can take an example of a bank transaction that is including around 5 steps. Right from the beginning of the transaction till the end of the transaction, you have 5 steps in between. And if any one of these step is failing because of any software error or power failure or any disk failure or by any other reason, then the then the system should remain as it is, which was at the beginning. It is nothing but it has to come to its original state. So that is called as atomicity. As we discussed about atomicity, the characteristic says if any one of these transaction steps are failing, then the system state or a transaction state has to come to its original state. So it is also called as rolling back the transaction. A little more information about atomicity is maintained in the presence of deadlocks, in the presence of software failures, application software failure, CPU failure, disk failure. So whatever the list which I mentioned just now, if any one of them is failing, the atomicity is maintained for a transaction and the transaction has to come to its original state. Now let's discuss about the consistency. What consistency ensures? Consistency ensures that the database is in a valid state before and after the transaction. For example, I have transferred 500 rupees into my father's account, and after transferring and completion of the transaction, my father is going to have 500 plus to his account, and I'm going to have 500 minus to my account. So the balancing is done here. The money is not missing anywhere in between. It is nothing but the transaction is completed. It's not stopped or it's not half finished anywhere in between. So basically it is not going to leave your database in half finished state. Now let's discuss about isolation. What is isolation about? Isolation is nothing but separating two transactions from each other. Suppose I have 1,000 rupees in my account, and my younger sister and elder sister both are trying to withdraw money from my account. My younger sister is trying to withdraw 500 out of my account. My elder sister is trying to withdraw 250 rupees out of my account. So both started the transaction at the same time, but out of those two transactions, one should complete first, the other one should complete after that. So it is nothing but both the transactions are not known to each other and they are isolated from each other and they are not known to each other. So in that case, when my younger sister withdraws 500 out of 1,000, then rest of the 500 balance should be shown to my elder sister, and out of that 500 she is going to withdraw 250 rupees. So at any point of time these two transactions are not colliding with each other. They should be separated and at the same time they should be isolated. Now let's discuss about the durability. Once the transaction is committed and completed over a database, even if the system crashes, there should be a way to get back the data again back. So, in other words, after the transaction is completed, all the changes that are made to the database should be permanent. The changes should not be lost in any case or in any case of system failure or database failure. So there is a logging mechanism that happens in SQL Server. When you start a transaction over a database, then there is a separate session created for you, and that session is going to make a note of all your steps, all your all your transactions that you are going to do over the database. So right from the beginning of the transaction till the end of the transaction, whatever the steps that you are performing, all of them are going to be noted or logged into a log file. So in case of any system failure, you or a database failure, we just go back to those log files and refer the steps that are done over the database and bring back the database into a original state using the logs.